that word sampling rate. So what is sampling rate? Sampling rate. So we have all these facts back here. So we have a total of, here's the bucket, 800 marbles, 300 red, 300 red, 500 white. And we grabbed a sample of 40, which is 16 red, they told me. 16 red in the sample, which means there must be 24 white when I subtract. That's what we're grabbing. And then what is going on when they say sampling rate? Sampling rate is, sampling rate, rate equals what percent, well, I'm going to just give you a little formula. Bless you. What number in the sample over total number in the population? It's what portion of the whole group are you selecting? So, yeah, so sampling rate matters. There's an interesting story. I always wish I had more time to talk about it. But in your book does a good job talking about when they were polling, when they first started polling a lot. It was a little before World War II. They started polling, and there's this one magazine, Literary Digest magazine. It was like Time magazine is now, or Newsweek. It was huge. It was like the biggest magazine in the country. It's since gone away. Literary Digest magazine. And what they did is they would poll the nation about a month before November election, every 4 years, and they would ask so many people. In fact, they would ask 10 million people. And the whole United States was only 40 million at that time. So they were asking 1/4 of the whole nation. That would be the sampling rate. That's what we're talking about, sampling rate. They asked 1/4 of the whole nation. So how many are in our sample? What was the inner sample? 40. 40 in our sample. How many in the whole bucket? 800. So it's 40 out of 800. See how I'm coming up with that? We're saying what portion of the whole bucket did you actually look at? So that's like this Literary Digest magazine that asked, they would send notes or letters to 10 million people, asking them a month in advance, who are you going to vote for? They'd get them all in, they'd calculate them all, and predict who was going to win. Well, that's the interesting thing. I mean, they're asking so many people. So somebody got this, we divide this, doesn't it come out 0.05? Which then, remember how to change a decimal to a percentage? Move it 2 places, 5%. 5%, so it's B. B on that one. Is that good? So what that means is we surveyed 5% of the bucket there. We looked at 5% of the bucket. Yeah, so Literary Digest magazine was very successful for 2 elections in a row. What chapter is that? Oh, yeah. They were super, super successful. Yeah, there's their little thing. They were super, super successful for 2 elections in a row. What was it? Anyway, they got to the 1936 election. Yeah, since 1916. The magazine had used polls to accurately predict the results of every presidential election since 1916. They'd had it exactly right. So that means in 1916, they nailed it. 1920, right every 4 years. 1924, 1928, 1932, just boom, 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 boom. They were just rolling them perfectly right. A month in advance. That sells magazines. If you can predict a month in advance what's going to actually happen in the presidential election, yeah, that's hotcakes, right? People are going to buy that for sure, right? They were the biggest magazine in the country. Then they got to the 1936 election, which was Republican candidate Alfred Landon and Democratic candidate Franklin Delano Roosevelt. Guess who won? You recognize one of those names, right? FDR was the president longer than anybody. He won a 4th term right before he died. I just finished listening to his passing away I'm listening to Churchill's biography. Anyway, so FDR won it. But they predicted that year, they predicted the other guy. And they predicted the other guy big time. In fact, here was what they printed in their magazine. Here's their quote in August ahead of time. They said, once again, we are asking more than 10 million voters, 1 out of 4. So 1 out of 4. That's 25% of the nation. That was how big their survey was. Representing every county in the United States to settle November's election in October, a month in advance. Next week, the first answers from these 10 million will begin the incoming tide of marked ballots to be triple-checked, verified, 5 times cross-classified in total. When the last figure has been touted and checked, if past experience is a criterion, the country will know to within a fraction of 1% the actual popular vote of 40 million voters. They said, we're going to get it right within a fraction of 1%. We always have. And their prediction, they predicted Landon that year in the 36 election, they predicted a month in advance that Landon would get 57% and FDR would get 43. That's a pretty big victory, right? We see the victories now are 50 to 51. No, that'd be more than 100. But, like 49 to 48 or something, right? Anyway, so that's what they predicted. The actual results, when it came in, were what? What was the actual results? Amazingly, the election turned out to be a landslide for Roosevelt. 62%. And Landon got 38.
How'd that happen?
They were off by 19% error. Biggest error ever made. In fact, the next week they printed, like their book covers this picture, Is Our Face Red? They were embarrassed. They blew it. I mean, before the nation, they were totally wrong. And at that same time, I'm going to answer your question, let me get to it. In that same election, remember, they asked 10 million people. 10 million, that's why it gave them that confidence. We're asking 1 out of 4. We're going to get it. In that same election, there was a young pollster, maybe you've heard of him, George Gallup, and he got it right by only asking 5,000 people. He just asked 5,000 people who were they going to vote for, and he nailed it almost exactly. And the rest is history. We all know how we now have the Gallup polls, right? George Gallup became a giant in the world of polling. Why did Gallup get it right when this giant, rich magazine get it wrong? Well, it turns out the way they got their information at that time is they sent out notes. They got their information by calling people on the phone, sending, and then they'd get their address and they'd send them letters in the mail. And they got, so I'm saying that wrong. They didn't call them. They used phone books, got the addresses, and mailed them. So it was all by mail. First point is it was all by mail. They mailed them, and people mailed back who they're going to vote for. They got the names to mail to by phone books, number one, by who was buying new cars, went to dealerships, got lists of names, and what was their magazine subscriptions, and club memberships. That was their source of information. Now, why is that bad? Well, do you remember what was going on in 1936 in the United States? The Great Depression. The Great Depression. 25% unemployment. And not everybody had a phone in their pocket like we do now, right? Phones were a little bit rare, especially for those having financial problems. Half the nation, or I don't know what the numbers are, but maybe a third of the nation didn't have phones, right? If you don't have enough food to eat, you don't have a phone. And new car dealerships, a lot of people weren't buying new cars, and they weren't part of some club, and they weren't subscribing to magazines. 25% of the nation was unemployed. So what ended up happening by getting information that way, they got information from the people that had a lot more money. They didn't mean to, but they got biased results, and that's where that all came in. They ended up asking richer people who they were going to vote for, and not only did they blow it because they were actually asking richer people, not meaning to, but that's what the effect of gathering information that way was. They also got almost nobody mailing that back. I mean, would you mail stuff back that comes in the mail? What do you think about this? If it's optional, it goes right in the trash for me, right? And that is for a lot of people. So now, remember that other thing we talked about, non-response bias? They were only getting the opinion of the diehards, the people that really cared about the election a lot. Like, oh yeah, I'm voting for whoever. It's just their whole life was that election. Those are the people that took the time to mail it back. They weren't getting the opinion of the average Joe and Mary. They were just getting the really committed people's, the more extreme people's opinion, right? That's what you always, whenever you do that. Gallup, on the other hand, George Gallup, he realized those were wrong ways to gather data. He sent pollsters out to talk to people in person. So they'd come up to somebody in person and say, who are you going to vote for? Now, somebody comes up to you in person, you're not as likely to turn them away, right? You're probably not going to say, you're bugging me, get out of here, right? If you're real hurt, you might. But most of the time, you'll give them a second, you'll tell them who you're going to vote for, and you move on. So you get rid of that non-response bias. And secondly, George Gallup broke the nation into the different kind of groups. George Gallup said, look, this much of the nation is poor, this much is rich, this much lives in cities, this much lives in the rural areas, this much is black and white, and this race and that race, male, female, old, young. He broke the whole nation up into those groups and then made sure his sample was a reflection of that same dynamic. Does that make sense? If 5% of the whole nation lived in the country and was poor and was white, then he made sure 5% of his sample lived in the country and was poor and was white. His sample was a little America, in other words. So he only needed 5,000 people, but it was a little America. And then he went out and he had his pollsters ask them directly, and he called it right within like 1%. George Gallup had a famous saying, then I'll move on to the other questions. George Gallup said, if you stir the soup well, only one spoonful tells you what it all tastes like. That's exactly right. That's the polling philosophy. And pretty much what we do today is imitating his methods. All right, so on we go. That magazine crashed. That was it. It went under. I mean, they tried to say we're sorry and we were wrong and we were bad, but who wanted to listen to them after it was giant corporation went down after that false election, after that false prediction. All right, on we go. Number 5. Suppose that the student is told that there are 800. In fact, let me go to a fresh screen on that. So you guys got sampling rate, right? You might want to put that in your 3x5 card. Sampling rate is number in the sample over total number in the population. Okay, on we go. Suppose the student is told there's 800 marbles in the container. Using the sample results, what's an estimate for the number of red marbles in the container? This is fishing. This is the fishing thing. Remember the counting the fish in the lake thing? Remember it's, what was it? Tag. Tag over total. Tag over total is tag over total. Remember that kind of thing? First catch, second catch, capture, recapture, we called it. Remember that whole thing? Instead of tag, though, how are we tagging marbles? They're red. We're talking about red or not red. The red is the tag. So it's just like using the little sample of marbles you got to predict the number red in the whole container. Okay, what are we talking about? We're talking about the whole container and the sample. So it's just like the fishing deal. Remember how we counted the number of fish in a lake? Here we go. What are the number of red marbles in the whole container? We don't know. Call it X. What are the number of total marbles in the whole container? 800. That's what we're saying we told the student. 800 total marbles in the whole container. What are the number of red marbles in the samples? Go back to the sample. Where it is. Here it is. Here's the sample, right? 16 red, 24 white. Total of 40 in the sample. So going back, 40 in the sample, 16 red. See how that's red over total, red over total? 16 red over 40 total in the sample. I don't know red over 800 total in the bucket, in the whole container. There it is. Solve for X. How do you solve for X there? The diagonal, cross multiply. 40X is 16 times 800. 40X is 16 times 800. 12,800. 12,000, so we have 40x is 12,800. Last step, divide by 40. Thank you. 300. So that would be an estimate. That's not really how many red. It's close though, isn't it? That would be a way of using your little sample to estimate how many red marbles in the whole container. Get the idea? You reach your hands in, grab out only 40, count them, find 16 are red out of 40. You're thinking 16 out of 40 are red, and I know there's 800 total in the container. That would mean about 320 are red in the whole container, if my sample is accurate. Now, no sample is perfect. So that would indicate, that's a way of figuring out how many red are probably in the whole container. That's what they do with polling, right? They ask people who they're going to vote for and assume that's the whole story. They count the fish in their little net. They assume that's the story for the whole lake, right? So 320D. Number 6. The value is 16 over 40. Now what is the value? 16 over 40. Let's go down the list here. Is it a response rate? That sounds kind of weird. Probably not. Let's keep going. Is it a sampling rate? No, we did sampling rate a minute ago. Sampling rate, bless you, is right here. Sampling rate is sample over total population. It's not that. Is it a parameter? Is it a statistic? Well, you're going to have to know the meanings of those words. I think I'm trying to guess. I don't know why this gives people so much trouble, but I think they don't know what a lot of the words mean, and then they get in trouble. So you got to know really clear, what does parameter mean? What is a parameter? It comes from the population. Remember I told you P and P, parameter, population, they go together. A parameter is something true of the whole population. So that would be, for example, an election, how many actually voted for Trump or Hillary Clinton, right? The actual number in the end on election day. That's a parameter. Whereas what was predicted ahead of time, that's a sample statistic. That's what statistics is guessing ahead of time based on a sample. That's what polling is. They guess ahead of time. They say, we think 48% will vote Trump and 49% will vote Hillary Clinton or whatever in their poll. Those are statistics. But then on actual election day, the truth, the whole population, those are called parameters. So you need to know those words for sure. They'll be tested. So no, P and P go together. Parameter and population, sample and statistics. So 16 over 40, that's the sample number. Some. Those are samples. So it's a statistic. That's what it is. It's a statistic. Because we know 16 and 40 come from the sample numbers. Good? On that, better move. I'm only... All right, they say the sampling error is most likely the result of. What do they mean, sampling error? What was the error? Remember, we predicted, when we grabbed our sample out, we just did that little fishing calculation. We predicted how many red would be in the bucket? 320. How many were actually in the bucket? Do you remember? 300. There's actually 300. So we're close, but we've got a little bit of an error. All polls do, right? There's no perfect poll. George Gallup's polls have errors, right? There's always an error. Now, I just told you about the whole Literary Digest magazine story, so you'd be clear in your mind. The problem with their poll, and many polls like them, is biases, right? Biases. They were asking the rich people, by the way they took information, they were effectively asking the rich people who they were going to vote for. So, is that what happened here? Why did we just get an error? We just grabbed some marbles, a little sample, right? And we tried to predict how many red in the whole container. We got off a little bit, pretty close, but off a little bit. What made that happen? Well, not a bias. We're not biased when we're reaching in and grabbing marbles. I just don't like red marbles. No, we're not biased. So, and non-respond, no, there's no bias of any kind. Cross out all the biases. Confounding variable. Oh, I haven't talked about that. I need to talk about that. Anyway, sampling variability. That's the answer. Samples vary. Sometimes you're reaching there's a little bit of luck involved, isn't there? Sometimes you get more red, sometimes you get less red. It's just a little bit of luck. Sampling variability. Yeah. Confounding variable. I left you guys with a melt question that I never answered. Is that true? Yeah. Didn't I give you a melt question? Didn't I say if you took the whole world and you broke it into two groups, those that have had milk at least once in their life, at least one time in their life, and versus those that never had milk. I'm going to tell you about confounding variable. Never had milk. These ones that have had milk at least one time die of cancer much more often than the other group that never has had milk in their life. That's true. That's a true fact. But it doesn't mean milk causes cancer. Why not? So here's really, this is one of the most valuable things, this chapter. This is one of my favorite chapters. Because it's valuable, because we're in the consumer age. We're in the information age. And information is constantly coming to us. We're consuming as well. But information is constantly coming to us. And you want to be a good consumer of that information. You want to know what to believe, what not to believe. So if somebody stands up and goes, hey, this just in. We took the whole world, we broke it into two groups, those that have never had milk at least one time in their life, and versus those that have had milk, those never, versus those that have had milk. Those that have never had milk versus those that have had it at least once, even if you don't drink it regularly now, if you've had it at least once, versus those that have never, ever, ever, ever had milk. The ones that have had milk at least one time, we have found, statistically, numerically, they die of cancer much more often. That's true. That's a true fact. Those numbers are true. But milk doesn't cause cancer. Why not? Well, how can those numbers be true? And yet, what they're implying, and this, you see how easy it is for somebody who wants to lie to you and deceive you with numbers? There's sayings about that, how easy it is to lie with statistics. Well, here we go. Here's an example of it. Just throw those numbers out, let them sit. Say nothing more. I'm not lying. I'm just throwing out numbers. No, you're lying if you're aiming to deceive, I would say. But anyway, how are they lying? What's going on there? Why are people dying of cancer without milk? Who are the people? Who are the people that have never had milk. Think about that group for today. We're talking about the world here. Has anybody in here never had milk once in their life? I don't think so, right? We've all had it at least once. Even if you hate it and never drink it again, you had it once, right? Who in the world has never even had it once? Are there people? Yeah, there are people. Where do they live? In impoverished countries, right? They never have milk because they don't have enough food to eat day by day. They don't have clothes. They don't have da-da-da-da-da, on you go. They don't have good health care. They don't have good nutrition. They don't have running water that's clean, right? Think about who this group is that has never had it once. That's a group really low, really much impoverished, right? In third world countries. This is an impoverished group. So wait. So what does that mean? Well, yeah, they don't die of cancer because they don't live past childhood usually, right? Usually you die of cancer when you're older. So all this is proving is that those who drink milk are usually in more affluent countries that live a little bit longer, so they have a chance to die of cancer later. Milk's not causing cancer. It's just these people are dying of other things too young to even have a chance to get cancer, typically. Milk is not causing cancer. But see how much it looked like it at first? And so what's going on here is age or poverty level or whatever you want to call it, all those kind of things are confounding, what are called confounding variables. They're tricking you. They're confounding you. They're the secret thing really causing the difference behind the scenes. See how easy it is for people to lie to you about things? Let me do one more. So that's not this, right? It's not a confounding variable. If you take all the states in the United States, see if you can pick this one up. Take every state in the United States, California, Vermont, Texas, da-da-da-da-da-da. Take every state. The states that have more Boy Scouts, 20 years later, have more criminals. That's a true fact. Again, I can say those numbers are true. That's a true fact. States that have more Boy Scouts than other states, if you go forward 20 years, you look at those same states that had the more Boy Scouts, now have more criminals. That's true. And I'm not doing something weird about, well, they moved out of state to go to prison. Nothing weird like that. I mean, people raised there are now in prison. That's true fact. So the Boy Scouts are cranking out criminals. Let's close them down. No. Like, that can be true, and Boy Scouts are not it's not causational. That's the trick. People can throw out facts, numbers that are related, but are not necessarily related in a causational way. Milk doesn't cause cancer, but there is a connection. It was age of death and poverty level and stuff like that. That was the hidden variable. What's going on here? Anybody explain this to me?
There's more population in that specific state.
Beautiful. It's population. It's population. California, for example. Do we got more Boy Scouts? Yeah, we got more everything. We got more Boy Scouts, Girl Scouts, men, women, criminals, honest people. We got more everything. We got more population. Yeah, that's a population. But see how it was confusing at first? Like, oh, more. See how easy it is to be lied to about that? Confounding. We got to think there's something behind the scenes. So the main lesson of that is just because two things are connected doesn't mean one's necessarily causing the other. It may be, but not always. We can't always jump to that conclusion. There can be something else causing them both, right? In this case, it's population. Good answer. Back to number 8. The sampling frame for this survey. What is sampling frame? A frame is something that a picture is inside of. It's something that you take stuff out of, a frame, right? You frame it. So let me try to help you that well. In fact, let me get this on a fresh screen here. So sampling frame. Remember when I was saying I'm going to find out the average age on campus, and I'll go over to the health science building and stand outside the health science building and ask people, how old are you? And I would not get a good average because those are nursing majors usually, and they're older. You got to go through a bunch of classes first before you can even enter the nursing program. I would get a much older than true average age of people on campus. It would be better for me to walk all around campus and ask people their age and make that average. That'd be more true. That'd be closer to the real average age on campus. So the frame, if I did that, my frame would be the health science people, because that's the only people I asked, is people over there near the health science. But that would be my frame. So your frame is the group from which you took the data. So for the Literary Digest magazine, their frame was telephone books and dealerships and clubs and magazine subscriptions. That was from which they got their data, and that's why they blew it so badly, because their frame did not represent the whole United States. So in this question then, so you always want your frame to match your target. If you want to know about the whole United States, you better ask people from all over the United States. If you want to know about the whole Fresno City College campus, I better go all over campus, not just at the Health Science Building. So that makes sense. Your frame better match your target, or you're going to get bad information. So the frame, what was the frame? In this case, we're just reaching into the bucket, right? We're just reaching into the bucket. So does our frame match? Yeah. We're not reaching, I'm just reaching into the left side of the bucket. No, we just reached into the bucket, right? So in our case, the is the same as the target. Our target, our goal was to know what's in the whole bucket. We reached into the whole bucket. Yeah, they're the same. No error there. Number 9, sampling method used in this example. What is the sampling method used in this one? It's just simple random. We just grabbed them at random. All right, let's go on to number 10. Okay, a lot of words here, blah, 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 blah. Let me see. I don't want to read them all. I'll go up as I need them. Let's go to the question. This study can best be described as, okay, I got to read it, I guess. So basically, they're doing this study. The main thing, you guys know when you write an English paper or something that in the, what is it, the end of the first page or first paragraph? Yeah, that's it. I'm not an English major or an English teacher. End of the first paragraph, you're supposed to give your thesis statement, right? You're supposed to say, this is what it's all about. This is what I believe and what I'm arguing for. Well, in the same way, in these little, medical things they're doing, pay attention to the claim. The claim is the main thing. What is their claim here? They claim, here's the most important words, right? Claim, what do they claim? That the combo of chemo and hormone therapy, tamoxifen, is more effective. The claim, let me just briefly write it, combo better. That's the claim. And that's really important that you're crystal clear on what they're claiming, okay? Then let's go on from that. Blah, 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 blah. They did some study. Group A received tamoxifen alone. So A, tamox alone. Is that a combo? No, it's tamoxifen alone. In other words, not a combo. What does B get? B received chemo and tamoxifen. That's a combo. Some kind of a combo. In C, chemo alone, but then they did get tamoxifen also. So it's some kind of different combo, but it's still a combo. They just did it in a different way. B and C are both combos. They're just different ways of doing the combo. Why am I focused on the combo so much? Because that's the claim, right? It's all about that claim. That's what you got to hone in on. The claim is the combo is better. So I'm just going to look at A, B, and C by, hey, you doing the combo or are you not doing the combo? Are you doing the claim or are you not doing the claim? All right, let's move on now. The study can best be described as, is it randomized controlled? Is it survey, simple random? What is all this stuff? Well, is it a controlled experiment? The A has the word controlled in it. Is that right? Is that appropriate? Is it a controlled experiment? What is a controlled experiment? Let me write that. Do you know? Controlled experiment has one group not getting the claimed treatment. Right? That's what it means to do a controlled experiment. You don't give one group the thing you believe in. That way you fight, right? Because if I had a new drug and I want to know if it worked, the best way to test it is to not just give it to a bunch of people and see if they're better, but also don't give it to another group and compare the results, right? You have one group that you don't give the whatever to. That's called the control group. That way you control to see if the drug is really making a difference. You got to have something to compare to. Okay? I know it's confusing. Let's read it again. Control experiment, one group called the control group that doesn't get the claimed treatment. What's the claimed treatment? Combo better. So is there a group here not getting the combo? Yeah, A. A's not getting the combo. They're getting something, but they're not getting what we really think works. They're not getting the combo. See how tricky it is? Because you might think, well, they're getting something, they're not control. No. They are control because they're not really getting what we really think works, what we're claiming the combo's better. A did not get the combo. They just got the tamoxifen. So they're the control group. We're trying to compare to them. So yes, A is right. This is a controlled experiment. We have a control group. Stratified sampling is what his name did, Gallup. When I said he made the United States, he made his 5,000 survey a little United States, same number of black, white, rich, poor, city, country livers, old, young, all that. That's what it means to do stratified. Maybe I should write that. So stratified means to break into small groups, like the whole population. That's not what's happening here. That's what they do when they poll now. When they poll, they make sure they do the Gallup thing, that they ask the same number of black, white, old, young, rich, poor, city, country, as are really in the United States. That's what they do. That's called stratified. Stratified, breaking into different strata. Stratified sampling. So that's not what we're going on here. Survey simple random. Well, yeah, it is a survey, but it's controlled. And quota, no. All right, so census, no, we didn't count everybody. All right, let's go on. Number 11. In this study, which is the control group? Yeah, we already answered. That's A, huh? A is the control group on that one. Number 12. This study is, is it blind, blind but not double blind, not experiment, double blind, blah, 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 blah. What's the blind thing? Yeah, blind patients don't know, right? You don't let the patients know because you don't want fake results. You don't, right? Because of the mental thing. And then what's double blind? Not quite nobody, but I know what you mean. The doctors don't know either. Some administrator over it all knows. Yeah, doctors don't know also. So both groups don't know. Okay, what if you read the words, did they know? Do they don't know? I can't remember.
Yeah, it's like the last sentence.
Is it, the last sentence? All knew which treatment. Oh, thank you. Yeah, so you got to read all those words, huh? They all knew. So this one's not blind at all, right? Yeah, not blind at all. They knew. On. Jump to number 20. Okay, the sampling method currently used in public opinion polls. Yeah, what they're doing now is like I said, stratified sampling. That's what they currently do. Which of the following will most likely make an instant online poll, CNN.com, ESPN.com, unscientific? What is the error that they make a lot of times in that? It is voluntary response. Because remember I told you that many people don't respond? Non-response bias. Because when they do the online thing, hardly anybody responds. They get fake results when they do that. You get non-response bias because it's voluntary response. Whereas if Gallup realized you got to come up to people and ask them, and then you tend to get the truth. Okay, number 22, the table there. Yeah, this one is always tough for people on the exam. This kind that we did one or two like it. These are our last few minutes. Let me just show you what you do. So here, let me put that one at the top. Okay, so here we have the golf score frequency thing. Okay, so what do we do here? Total number of holes of golf Joe played on Saturday was. Okay, do you understand what this is saying? Frequency means how many, doesn't it? So that means 5 times Joe got a score of 2. 8 times he got a score of 3. 11 times a 4. 5 times a 5. 3 times a 6. 1 time a 7. 2 times an 8. And 1 time a 9. So if you wanted to write, I would encourage you to write these out. I think it's worth it. I would go 5 2s. 1, 2, 3, 4, 5. Then I would go, okay, what's next? 8 3s. 1, 2, 3, 4, 5, 6, 7, 8 3s. Then I would go, okay, what's next? 11 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 4s. Okay, what's next? 5 5s. 1, 2, 3, 4, 5. And what's next is 3 6s. And then next is 1 7, 2 8s, and a 9. There we go. So that's what that's really saying. Does that make sense what that table's saying? It's saying all those different golf scores. are the scores that Joe got. So what's the total number of holes of golf Joe played? You would add all these up, huh? Comes out 36. He played 36 holes of golf. Frequency is how many? Joe's average golf score. How do you figure Joe's average golf score? You got to add, well, median, the average here means add up and divide by 36. There's 36 total. Now, how are we going to add all those up? I mean, I got to add all these numbers up. Well, you can use multiply, huh? 5 times 2, 8 times 3, right? In other words, do you see what we would do for the average? We would just come in here and we would go 2 times 5, 10, 3 times 8, 24, and just add them all up and divide by 36, and you'll get the average. I am running out of time, so what I'm going to do is I'm going to encourage you to go to YouTube. Can I just show you that real quick? Because I've finished this before in other classes. Somehow I ran out of time more in this class. So let me go show you how to find that. Just go to YouTube. Type in my name, your favorite YouTube site, Brett Herron.
Smash the like button.
Yes, please. No, somebody asked, just a couple hours ago, somebody said, "You making money off YouTube?" I said, "I don't even know how to make money off YouTube." All right, so come in here and playlists. So go and go to Math 40. I mean, it's silly for me to be teaching you about you. I mean, my daughter set it up for me. I mean, I don't know how this stuff works. So anyway, but my point is, look at my history. At old classes over the summer, I did cover this more thoroughly because I'm leaving off half these. So just come over here. See this over here, guys? Just roll down over here. Look for my old, what is it, number 4? Practice number 4. I'm just rolling down. Practice number 5. There's 5 from summer. Practice number 4. There it is. Summer 17. 58 minutes. Click on that. You get a much more thorough covering of those things I didn't make it to today on that. So use that for your